Hello and welcome back to another video. Today we're doing another Leetcode problem. Today's question is Leetcode problem 3, longest substring without repeating characters. Now this is a medium rated problem and it reads, given a string as find the length of the longest substring without repeating characters. Now all this problem is asking is if we are given some input s, pretend this is a string, we want to find the biggest substring within it that does not have any repeating characters. So if we look at it right now, we have this substring with a length of 3. But then we also have B, C, A, also 3. What else do we have? I believe 3 is the longest substring here, yeah. And that's all it's doing. So if we were to use this substring instead, A, B, C, A, length of 4, this is not allowed actually because we have a repeating A. Now my first approach to this is using a sliding window, and how we do that is we have a left and a right pointer, and all we do is we check the letter that's at the right, A, right now, and see if it's already within this substring. Now since left and R are in the same position, there is no substring. Then if it's not within the substring, then we move R. B. Is B within the substring A? No, because now the substring between L and R is just A, right? And B is not within it, so we can keep going. We can go to C. Is C within A and B? No. So we can include it, keep going. Is A within it? Yes, it is. So actually, we have to move to the left. And we also move to the right. Is B within it? Yes. So we move the left and we move the right. Is C within it? Yes. Move the left, move the right. Is B within it? Yes, it is. So we move the left, but here we actually have to move it twice while moving the right once. Is B within it again? Yes. Is it still within it? Yes, move it twice. And while doing this, we also have to store some letter, let's call it M, which stores the maximum between, which stores the maximum length of each substring, basically. Now, the problem with this approach, and I didn't realize this the first time I was doing this, is you would think this is a standard O to the N approach because we are just going through every single letter. But the problem with that is, let's say our R is here and our L is here, right? Here we would be checking A against the rest of this substring, and the problem with that is actually an O to the M operation, where M is the length of substring. And if we look at the worst case, let's say we are given a string that is completely unique, no characters repeat at all, and once we get to the end we have an L and an R. We're checking F against the entire thing, so at this point M is the same thing as N, well, N minus 1, but it actually becomes an O to the N squared operation, or sequence, yeah, which is not very ideal. We do want to try to shoot for O to the N, and the way around this is to actually use a set. And that's because a set allows us to store characters and remove them, but we can actually look up these characters in O to the 1, which makes this total sequence, total algorithm, O to the N. So how this would work with a set is we would have the same exact thing with left and right. So left and right. And we would just check. We would check the letter that right is on. Is A in the set? No, it's not. So all we do is actually add it. Now we move. Is B in the set? No. We add it. Now, is C in the set? No. So we add it. And this whole time we are storing some variable M, which is just holding the maximum letters. Now we go to here. A. Is A in the set? Yes, it is. So actually, we have to remove it. We move this L, but we have to add it again anyway, so we kind of undo the operation. But let's just pretend we have to do this. Now, is B in it? Yes, it is. So we have to remove it. Move the L. And the reason why we are removing it is because we're moving the L. This B right here is no longer in the subset. But the reason we add it again is now we have a new B, which the operations do cancel out. But if we go here, is C in it? Yes, it is. So we move it out. Move this L. Oh, but we have to add it again. Now we move again. Is B in it? Yes. And what we have to do is actually, when we are removing the letters, we aren't actually removing the B itself. We're removing whatever letter is held here. So actually, we remove the A because it's at the L. Now we move it. B is still in it though. So we also have to move this. Oops, we moved this as well by accident. Right? Now we move. Oh, but right has a B. So we put a B again. And we do the same thing again. R is B. And we have to move the L to the left, so that means we get rid of the C. Oh, it's still in it, so we move it again. We have to get rid of it again. And we add it back. So, and this whole time, our set never exceeded our length of 3, which makes that the final output. And if we look at their first example, an output of 3 is the correct answer. So let's head over to Leetcode and start coding our solution. Alright, so now that we are over here in Leetcode, let's start by creating some variables. Let's create our variable m, and this will store the maximum length of our substring. Let's create our pointer L, and we want to start it at 0. Now we could also create r equals 0, and that is how you would do a sliding window usually, but let's not do that, and you'll see why in a second. And let's create our set, which is equal to character. And now, so this is wrong. This is creating a dictionary. We have to use the operation set. And the reason why we're not going to create an r variable is since we are incrementing r every single time, we don't actually need to use a while statement and manually increment it. We can just use a for loop. And this for loop is going to be for r in range of the length of s. So r will go through every single character. And if you remember, the first thing that we need to do is while s at r is in characters. Remember, because as long as that letter exists within the substring, we want to keep moving to the left. So we want to use the character.remove operation. We want to remove the letter before we actually move L, because if we move L, we will lose its reference to that character. And now we want, after this while loop is done, that means that the character at right no longer exists in the substring, so now it is a valid character to put back, so we can actually add it. Character.add is equal to s at r. And we need to update our m. And m needs to hold the maximum value between m and the length of character. And that's because we don't want it to update if m is still bigger than the maximum length of the substring. And we could just return m. And if we try submitting, we get 54.71. And this ends up being an O to the n time complexity, which means we're all done here. This was an easy problem today. I'll see you guys with another problem in the next video. Thank you.